Thank you very much for invitation. Okay, I will talk about unitarizability problem for classical p-Adic groups. I will try to avoid technical details as much as possible, very often simplifying things or even oversimplifying things. I will start very elementary and some also with some history which is related to the problem and from which we may see what we could expect in the future. So first, if you have a locally compact group G, then by G hat is denoted all the equivalence classes of irreducible unitary representations of G. So this is a unitary dual. Actually, our story begins in 1964. When Gelfand and Naimark wrote what is unitary dual of S and C. It was announcement, just announcement. In 1950, they wrote a book called Unitary Representations of Classical Groups, related to their announcement and which contains some proofs and some important ideas which had important influence on the future of representation theory. Stein showed in 1967 that their list is not complete, actually constructing some more representation. Actually, the question of unitary dual showed to be much harder than Gelfand and Naimark expected, and Harishchandra created a strategy to approach unitary dual through non-unitary dual. Non-unitary dual is defined similarly, but just like unitary, but one drops requirement of unitarity. So it has also several different descriptions. So what he did for groups, semi-simple or reductive groups of real numbers, and it has two steps. So first was to classify non-unitary dual, and second is unitarizability problem. Just describe subset of unitary classes in non-unitary classes. So this was for real groups. Bernstein extended this strategy to p-Adic groups. So this is a question which we are going to talk about, and this is usually a split problem in two steps. So first is construction. So of list of irreducible unitary representation. So this was exactly what Gelfand and Naimark were doing. And second is exhaustion, or completeness of the list, of this list. So like in commutative harmonic analysis, where a unitary dual consists only of unitary characters, this set carries natural topology, defined by approximation of matrix coefficients. And in construction of irreducible list of irreducible representations, hardest part is to find isolated representations. So the actually, they are usually hardest. There is only one exception. So this is trivial representation. Is let's say for simple groups and of rank higher than one is isolated. I said this is only essentially a very simple representation, but even the fact that it's isolated, it has a number of interesting consequences, and it has been studied a lot. So this is famous property T of Gelfand. So one way, if you want about construction, one way to find unitary representations is just let's say study some natural unitary representation, and each such representation you can decompose into direct integral, and support of the measure decomposing is denoted by support of phi. This support can be also described without direct integral, just looking again at approximation of matrix coefficients, so-called the weakly containment. Okay, so one first representation which one could look is L2 of G. So actually this representation in the real case was studied very much by Harishchandra. So support of this representation is attempt representations, and also here again finding isolated representations is interesting. For example, in this case, a representation pi here is isolated for G semi-simple if and only if pi is a discrete series. Okay, so okay, so actually, Harishchandra, big part of his work was related to this construction of these isolated representations of discrete series, decomposition of these representations, and so on. So difference with complex groups is that for complex group you can look at L2K and everything, each irreducible representation is here. So what we do not have here natural representation if G is not compact, and so we may ask, is there a representation which contains actually interesting unitary representation of group G, and by interesting first, which we would mean isolated representation. So can we not? We cannot find containing all, but let's say that contains at least isolated representation in the support. So big progress was done in the mid-70s when in the real case for reductive groups over reals, non-unitary dual was classified, actually not only non-unitary but Hermitian dual, and actually it was done by Langlands, Knepp and Zuckerman, but even Knepp and Zuckerman gave explicit formula for invariant Hermitian form. But what turned out that deciding if this form is positive definite or not turned still to be a very, very hard question. Okay, so this was mid-70s. So in p-Adic case, situation was started to develop much later. And actually, first, essentially first paper on unitarity in p-Adic case was written by Bernstein, published in 1983. It's actually a great paper containing very nice ideas, some belonging, some of them belonging to people from Gelfand school. Actually, what Bernstein did, he gave algorithm for deciding unitarity of let's particular representation, irreducible representation. So actually, and he raised also question. So this is for GL groups. In p-Adic case, and he asked, can GLN be given by reasonable explicit formulas, or we can only have algorithm. So he indicated also that if answer to this question would have same consequences for general reductive group and real or p-Adic. Surprisingly, we got the answer to this question in 1984, actually published 1 or 2 years later. And actually, his answer is pretty simple. We will need this later. And actually, this is kind of model which we would like to have in for other classical groups. So just to describe, let me remind of Bernstein-Zalevinsky notation for parabolic induction. Okay, so this is, if you take two representations, pi1, pi2, just of two GL groups, you put here, extend here, you induce, and this is so from pi to J. Okay, so this is well known. And so now denote by absolute value, modulus character. By nu denote absolute value of determinant, and denote by dfu all discrete series of GL groups. Now, so for sigma discrete series and n natural number, look at the representation nu to n minus 1 half sigma times, and now decrease exponent by 1 each time. Okay, sorry. So this contains, this has unique irreducible quotient. Sorry, U. And this is called Speer representation. So this is unitary. Denoted by BF rigid all span. And denoted by BF, BF rigid, union complementary series, okay, so nu to alpha pi times nu to minus alpha pi, when alpha pi is in BF rigid, and alpha is greater than 0, less than 1/2. And denoted by MF, MBF, sorry, all finite multisets in BF. So now answer is very simple. This is theorem which tells that pi 1 to pi k, you send this to induce, is bijection from MBF to union of unitary duals when n is greater than 0. Yes, okay. So answer is very simple, and actually now we can come to what missed Bernstein and not Bernstein, Gelfand and Naimark. They missed, actually their claim was more or less the same, but they missed this representation. Where is this? Okay, so they missed okay, so they have here, but they put pi equal u sigma 1. They had here, but they missed this pi equal u sigma n for n greater than or equal to 2. So actually it's they missed, but it's not that bad. So it was basically the year when non-commutative harmonic analysis started. So next surprise came that this description also hold over okay, Archimedean fields. So this is why I'm mentioning Gelfand-Naimark. It was surprised because somehow in Gelfand school they were using analytic methods, but out of Gelfand school people were using Lie algebra methods, and the Lie algebra methods doesn't make any sense in p-Adic case to use in unitarizability. Okay, so next thing is just what I'm saying. What are isolated representations? So we describe this topology, and it's very easy to describe. So now, when okay, we will denote by CUF all irreducible GL Caspidal representations. Okay, representations Caspidal. So then for each sigma here, again, an n natural number, here's unique irreducible subrepresentation, which you denote by delta sigma n. So now, again, description of unitary, isolated representations is very simple. So pi, irreducible unitary representation, GL representation, pi is isolated. So correct notion would be isolated modulo center, but okay. If and only if pi is equal u delta rho n M, where both N and M are different from 2. So each, okay, so, okay, we are now coming to the question, can we find some representation where all these isolated representations are living? Actually, now if you take a global field K, such that, and place V, that globalization, okay, completion is F. So now all this, so this is the result of essentially Jacquet. These representations are in support of L2, GL, and K. GL and KV. Sorry. Adults over K. Okay, I think no. Yes, okay. So what is interesting also that result of this is Miller and Spee tells that this all these representations okay are isolated in the support of this representation actually, and also for n equal 2 and m equal 2. So here you do not have exception. Okay, one could I think that Ramanujan conjecture, generalized Ramanujan conjecture would imply that this only, but isolated. Okay, so this is the end of GL story, and now we are going to classical groups. But although in decades after this, were actually very interesting things were done, and important. I will maybe come later. So people who are doing on this include Badulescu, Enyar, Lapide, Minguez, Renard, and Secher, among others. Okay, so now we go to other groups from now Gelfand and Naimak book from 1950. These are other classical groups. Okay, we would like to have a similar description. So, okay, describe them, know what are isolated points and where they live. So here we will talk about groups G equal SP to N F and SO to N plus 1F. So split. Okay, so we will denote this either by G or GM if we want to specify the rank. And we could cover more groups like unitary and so on, but essentially you'll see the group itself doesn't play the role, but what really plays a role is, let's say, some other data like reducibility points and so on. So because like here, actually F is important, but really what enters these theorems are discrete series, Caspel representations. Somehow they are black boxes. Okay, so next thing what we will do here, extend Bernstein-Levinsky notation, this for parabolic induction. Okay, so this will we will denote this. So this is here's GL representation, and here's some representation of G N representation, and so this is induced representation. Let's say I will write roughly how this looks. Will not go. Oh, sorry. So here's zeros and here's something. So and you put here pi, here's sigma. Okay, so we will not. So now, for the difference of what Gelfand and Naimark wanted, they wanted to have some candidate for unitary dual, but here we do not have any candidate. But for this, we would like to guess how could look unitary duals, and for this we will just recall of some partial classifications that we have for classical groups. So we have actually 3 examples. First is generic unitary dual. Actually, generic representations were quite a lot studied by people in automorphic forms. And also, always we would like to know something what could call reasonable explicit classification, just what Bernstein was asking. Okay, so in this case, representations which form generic unitary dual look like something like this. Nu to delta, alpha k, delta k, okay, sorry, times sigma, where alpha I are greater than 0, delta I are discrete series, and okay, and sigma is a generic tempered G representation, so representation of a classical group. Okay, so now I would okay, so satisfying some essentially combinatorial conditions. Okay, so do you know how to get this? Oh, okay. Okay, so actually I said these are some technical conditions, and you have written them up, but the idea is not that you try to understand this condition, but just to see that it's some set of conditions which are, okay, they are not very simple, but also it's not something that you need several pages to write them. Okay, and also this classification was handled in terms of Langlands classification, so of unitary dual. Yes, non-unitary dual. So second case which we have is unramified unitary dual. So all this is for classical groups. Actually, this is kind of opposite classification to this generic, and essentially you can get this from this. But what is interesting is also to get independently, because you handle this by Langlands, and here you cannot handle this by Langlands, but by some kind of Zalevinsky classification. And here answer is that these are representation of kind of form very similar. Phi, let's say k times sigma negative. Okay, where this alpha are greater than 0. Phi are unramified unitary GL characters, and sigma negative is negative unramified representation classical group. What means negative? So you have Castleman criteria for score integrability. Actually, this is same thing like this Castleman criterion, but at all places you just reverse inequality. So these are called negative. So if this, this is criteria for tempered. If you reverse for score integrability, then you get the notion of strongly negative representation. Okay, so here the list is essentially similar. Okay, let me just. Okay, so. Okay, I do not know how to get the other. It's okay. So it's very similar. This type of conditions is my idea is only to show that again, this is something what it's not very hard to understand. Also, here we okay. First of all, unitary dual consisting of unramified representation will be denoted with this superscript 1. So I think superscript 1 denotes a trivial representation of a maximal compact. Okay, so we got also a topology here. And actually, what I wrote combinatorial formula for isolated number of isolated points. You have a list of them. And put in Mathematica. So I think 15 years ago, maybe a little bit less, maybe 10, I got following example. So this is the biggest strength that my old iMac could compute. So it tells you number of isolated unramified representation in SO 451F is, okay, so I will not read number, but I'll write 1, 289, 535, 202, 500. Okay, so it's some extremely big number, but I wrote this only to indicate that this is not completely trivial, but you have a really complete control of what is going on. So following thing for all these two classifications, these representations which are isolated, they show up again in support of something GK. In this representation of square integrable automorphic forms, where F is, so here's K. And F is isomorphic to completion of K and F. So why these classifications are easier? These classifications are easier because here non-unitary duals are much simpler in general. Irreducible representations are fully induced. So in both cases, so for example, for generic, it's a unique irreducible quotient, but it's actually whole representation. So this and following thing is that it's very easy to trace this representation when you induce and when you have a reducibility, you are just interested in same type of representation and you have only one generic or one unramified representation. So second, so this is basically, it's quite easy to get unitarity. In this case, everything is very classic, so he's, now you can get from Arthur, but Mujic got them just looking at residues of Eisenstein series. So now for exhaustion, what is useful? So I said this. And second thing is that this is not very simple, but it's simpler than in general, that you have one-dimensional complementary series. When you have one-dimensional complementary series, rather specific, that after first reducibility point, you have unitarity, and here you must have non-unitarity. So then whole exhaustion story goes in a way that you, when you have very far some representation, okay, you want to show everything here that it's, okay, so you have this list, whatever is here that is non-unitary, that you have, let's say, some standard construction of unitarity, like complementary series, limits of complementary series, and so on, that you suppose that it is unitary, and you bring it here, and you get that it's non-unitary, so you get contradiction. Okay, so it's pretty easy, but let me just say that this theorem, although it's relatively simple, but even proof of this simple case, it takes, let's say, maybe 30 pages or something, so it's not easy. Okay. Okay. Also, this this tells what I wrote, that we have a very big difference between classic, between, let's say, classical groups and let's say SL groups. For SL, this in the space of if you look SL and K, SL and AK, L2. So here there is a trivial representation, and okay, so this is so okay, so this I think trivial must be here also, at least by okay, so this is isolated here. Okay, so not, okay, maybe I will just what I wanted just to say, the fact which we wrote for SO 451 F, that you have great number of isolated representations. Okay, I didn't want maybe to tell this, but for SL and F, so here's the only trivial representation is isolated. Oh, sorry. And in this case, you have so many. So about the fact that this trivial representation is isolated here, there is number of papers, books, and so on. So now the question is, just here you have huge number, not only for these groups, but for these groups, you have so many isolated representations. Is there some arithmetic a reason for this? Because this case that you have only one was studied much. Okay. Okay, so next thing, so we were talking about two classifications. So now we would like to think about general case. We do not know, but now let me try to start to do what Gelfand and Naimark. Can we guess somehow list of irreducible unitary representations for classical p-Adic groups? I just know, but one, these two classifications would say that we can think about something like here. Okay, where alpha I, okay, okay, greater than 0. So then this psi I are Speer representations, and sigma is Arthur type representation. I'm just trying to guess because in this case somehow tempered and these negative representations are what is here, and this representation, Speer representation for u delta n. For delta 1 you get, for n equal 1 you get delta. For delta unramified character, you get this. Okay, but just this, what you would guess, and then also that irreducible unitary representations isolated are in a representation of score in the space of score integrable automorphic forms. But this is not actually this thinking in this direction, but it's not good. There are counterexamples, but maybe not that they may be unitary, but you do not have pictures of this type. Encouraged by a very significant work of Lapide and Minguez, in which they got GL classification just using Jacquet modules and the fact that cuspidal reducibility in the field case is 1. Okay, so they got a classification which I wrote for GL groups in p-Adic case. So in this way, they, let's say, were able to avoid all these beautiful ideas of essentially members of Gelfand school, including Gelfand, Naimark, Bernstein, Kirillov, and so on. So now, third classification, which I will tell a little bit, is for, okay, so okay, maybe first to introduce something, what is called Janssen decomposition. If you take P, a GL representation, irreducible, then you can decompose this in in a product of several irreducible representations where pi I are supported by different cuspidal lines. It means that elements of support are in such sets where rho is going over Cu F. Okay, so then almost trivial fact is that pi is unitary if and only if all pi I are unitary. So we would like, actually, this is something what helps thinking in GL case, but really you do not need to use this. But we would like something of this, like this for classical groups. And so this is what was done by Janssen. Actually, what he did is that it's technically much more complicated. He attached to pi a sequence of representations of classical groups in a way that each pi I is sub-representation of tau I times sigma, where sigma is cuspidal, and this tau I are supported by different cuspidal lines. So this is by different such things. Okay. Actually, this attaching has a number of nice properties. This is tempered if each of them tempered score integrable formulas for Langlands quotients and so on. But here, just what is not clear, but I would just put as conjecture. So that pi is unitary if and only if all pi I are unitary. Okay, you can also here ask, is pi isolated? If you believe this, okay, that holds. If is pi unitary isolated if and only if all pi I are isolated. Okay, so the following conjecture would, if it holds, would reduce to a question to representation supported by only one cuspidal line. Okay, even if it is not a true conjecture, this problem is very interesting, but I hope that this is true. Okay, now we are now just reduced to when you fix cuspidal representation and then sigma, okay, rho cuspidal sigma cuspidal G representation, everything is irreducible. And then you look at so set denoted by CL rho sigma, all irreducible subquotients of nu to alpha more. Okay, so you can write this rho k times sigma, where rho I are in nu to r rho. Okay, so now just recall that Megland singled out all cuspidal representations in Arthur classification. Very simple, is that some alternating and so on. I will not write, but just okay. You have a description of this. So another thing, what is important for us is there exists unique number alpha. Or we will denote also by alpha rho sigma greater than or equal to 0, that nu to alpha rho sigma rho times sigma reduce. So what is known? It's known that these numbers are either integers or half integers. Also, what is a fact is that Megland has a very nice formula for them. In our paper, it was on discrete series. It was called basic assumption, but it's now proved. But it's a very beautiful formula because it on one side it's simple formula. You have analytic information. So this is another side. You have arithmetic information. So you read this from this lengthless correspondence. Okay, so now what is, I will write conjecture, which I will not. Unitarizability in CL rho sigma depends, so whatever it means, only on alpha rho sigma. So not on rho and sigma itself. Actually, to write conjecture, all details, you need to go to parameterization of tempered representations and so on. We could actually, I'm sorry, probably will not be able to see this third classification, but just what you have in this third classification is only this reduced just exponents. They show up, not this rho and sigma. So this reducibility, this alpha rho sigma can be 1, 0, 1/2, 1, and so on. And actually, they all show up. So that it means that you would have, let's say, infinitely many such cases. Let's say for GL of a field, you have only one. You have a reducibility at 1. Let me say that this work of Lapide and Minguez, it's not only for field, but what is great that it's also for all division algebras. So now we would like to classify what I'm saying, just to get some idea how to guess unitarity. Representations of form nu to alpha 1 rho 1 times nu to alpha k rho k. But this is really very simple. So times sigma, where rho I capital GL representations, sigma is capital G representation, alpha I real numbers, and also what really is just non-trivial part is, and it's easy to reduce to the case that these are self-dual representations. Okay, unfortunately, just maybe I can, let me see, just let me, maybe I can, okay. So this is, okay. Now I have skipped this unramified, but here's this unramified theorem. So I have forgotten this generic was Lapide, Mujic, and me, and this is Mujic and me. Okay, so now we have done this, but let me go now to the third. Okay. Okay, so this is this classification. So essentially, what I'm saying, it doesn't really depend on this rho and alpha. Okay, they show up, but always the same. But what is really important? What happens with these exponents? Okay. So what I did, okay, so I have forgotten to tell that this is very easy case. So this is k equal less than or equal to 2. And also this is the case where rho 1 equal rho 2 equal rho 3. So this is easy the case. And again, we have characteristics which we have observed before. This classification is relatively okay. It's not completely easy, but it's not something extraordinary. But the proof, so this is this which appeared in the memoirs of AMS last year, is it has about 100 pages, or a little bit more than 100 pages. So it's somehow typical, excluding GL, that you have reasonable, let's say, unitarity, and actually unitarity here is it's not complicated to get. What is really complicated to get is exhaustion. Okay. Also, second thing is that from this one can see that in this case, unitarity of all isolated representations. I didn't wrote what are, but just you can conclude at which set they are. They are also in automorphic forms. Now I'm this picture which I mentioned. You would like to have this spe. Okay, spe 1 times, okay, something of this type, and then you have something sigma Arthur. Okay, so there are some problems with if you expect this. Problem is that, for example, let's say, let unitarity be at, let's say, 20. Then, for example, nu to 18 rho times sigma is Arthur type representation. So it's a little bit surprising. So, but what it means? So it means that if you put here, so then you do not have, let's say, some kind of unicity and so on. So here you need to try to let's say, put smaller number of then Arthur representation. So all Arthur representations. Just I will finish just to say what are here critical points. Could let me see. So this is okay. Where is this? Okay, so I have okay. Now we have following definition. I would just a representation pi in non-unitary dual will be called representation in critical point if there exists alpha 1 to alpha k integers or half integers such that pi is contained in nu to alpha 1 rho times nu to alpha k rho times sigma, such that okay, so this alpha, okay, so sigma is cuspidal, such that alpha 1 to alpha k, and now sigma, alpha rho sigma is z segment. So it means some collection of numbers just containing 1/2 of z, but okay, so I think this you understand. So whole proof of exhaustion, and so goes that you handle first these critical points, and then actually this determines everything. Okay, so now what is I think very important conjecture. So what I said, essentially everything is determined by what happens in critical points. Representation pi in critical point is unitary if and only if is of Arthur type. Okay, so this is because just these representations are very hard. Just they determine it's hard to get their unitarity. One thing, and another thing is that somehow, let's say, in all these cases up to now, their non-unitarity was giving non-unitarity here. Just and a remark at the end. I think that now it's the right moment to try to think how would unitary dual in this case for classical groups look like. Because just writing unitary dual is somehow has shown to be much easier than guessing than showing exhaustion. This is one thing, and another thing is that it's now it's a really new moment when we have a very efficient way to getting new complicated unitary representation. So this is this representations from Arthur packets plus McGlenn description of construction of elements of Arthur packets, because you have Jacquet modules are very strong tool. So this Lapide and Minguez show this, but before, let's say, unitary parabolic induction was wonderful, but Jacquet modules were never used for constructing unitary representation. This is McGlenn construction, and now extended by just by Atobe, so give you a very efficient way to get in some combinatorial way new. You can get many isolated representations and so on. Okay, thank you. Sorry for 3 minutes over. Okay.